Okay, so today I'll be talking about visualizing architecture, by which I mean new ways to look at what you've already got. So a little bit about myself. The Centre for Australian Weather and Climate Research is a partnership between the Bureau of Meteorology and the CSIRO, and I've been working there since 2002, and I've been using Python pretty much exclusively since 2006. I had to write a little bit of C code about a year and a half ago, but that didn't go so well. So, now I stay away. No, I went fine, just kidding. So I have a background in artificial intelligence and natural language generation, basically by virtue of my current job, which I've now been doing for some time. And I have a philosophy diploma and an MBA as well. So the MBA was a bit interesting. And as a result of all of that, I've ended up with some of my own ideas about what makes good architecture. So I may not be following exactly what everybody's familiar with in terms of how to design things or how to build things, but the point of this presentation isn't to tell you how to do things, it's to tell you how to look at what you've already done and then think about it for yourself. So what does visualizing architecture mean anyway? So let's start connecting with the word visualizing. So certainly for me this is true, and I think it's generally true, that people will connect visually more than in any other way. If you can show somebody really clearly in a way that they can just look at and go, I see it, that's a real gift in terms of interpretation of what you're putting in front of them. So it's critical to how we design, calculate and relate to the world. So let's just start with just looking. So some of you may be familiar with this. Now let's work out how I can push play on this video. This is something called Gorse. And this will make a video watching you do check-ins into your repository. So this is matplotlib. And I've never really thought about watching check-ins quite like this before. I think it's quite pretty, actually. What it means is perhaps a little less obvious. So every time I skip forward in time, you'll notice it's redrawing its graph from the start. And let's take a look at going here. What we're looking at is how people are choosing to interact with a code space or a code base. It's not necessarily telling us about what they're doing or what the content of their work is. It's telling us how they relate to the lines of code that they've got in their repository. And so you can see that the big flashes come every time you skip forward because it's generating the new graph from scratch. But you can see a few things. One is that people don't tend to isolate just in one area. You don't have people working in just one file. You tend to have people moving all around the repository, touching lots of things. The one thing that really came across here is that it's a pretty organic process. And you can get in here, and if you get a bit advanced, you can get gravatars and images of who's doing what going in there. And if you just kind of watch it for a bit, no one of these is just working in one space. We don't have a clean hierarchy in the organisational model here. I don't do matplotlib. When I say we, I mean nobody. The greater we. We don't work by just putting ourselves in buckets and just going, I'm just going to work on this bucket forever. The changes might come in because of some business reason, something that was important isn't important anymore, so we move where we're working. Or maybe what we're doing is distributed across so many files that we just can't work that way. We try to organise our code that way. If you think about what design principles for good code is, it's all about encapsulation and good APIs and don't repeat yourself kind of methodology and things that you can reuse. But it's not actually how we sit down and write code. So that's what I took away from that. I don't know whether that's what you took away from it, but you can take this and run this on your own code back at work. So if nothing else, you can just check this out and run it, and that's one cool thing you can take away from the conference. So here's matplotlib's file structure. So this was a way that an application I found, obviously generated this image, and it's a way just to take a look at the trunk of matplotlib and just go, well, what's in it? Again, I'm still looking at the file system. I haven't opened any codes. I haven't read a document. I haven't trusted anything that isn't completely true. This is directly from the file system. It doesn't lie. So one might conclude that providing an HTML set of documentation is important, that this particular project conducts itself with strong emphasis on users, judging by the user's guide and course directories. And in fact, the source code is tucked away down in one of these leaf node, or relatively leaf node matplotlibs. So there's a subdirectory there, matplotlib, where the code actually is. So one might choose to imagine that this is true about the project, that the code structure matches what's important to them about their project. But let's take a look at a few other applications. Is this how most applications look, or is it not? So here's Twisted. And straight away, to me, this is far different. Twisted generally being a different kind of an application. So what we can see here is that straight away it's broken up into more and smaller parcels. That may be good, that may be bad. It's really going to depend on their needs. This could be, either one of these may be a valid or an invalid choice. I'm just trying to show that we have different ways of building these applications in practice. And here's Bash. So it's so flat that almost all of its files are just in the top level directory. So every single one of those final leaf nodes there, that's just a file. And then they've shoved all of the tests in a single directory, and there you go. So one could either say that's kind of perfectly disorganized, or otherwise maybe everything's just at a grasp. And here's some software that I wrote, which is different again, called Benchmarker.py. Now, I'm not holding this up as good software. I'm just holding this up as something I can talk about it because I wrote it and I don't criticise anybody else by criticising it. So, as it happens, I love its file system structure, but as we'll find out later on, I hate its code structure. And one of the things that I've done badly is to relate the file system structure to the code structure. So I've broken one of the fundamental ways that people can come in and look at this code, is that they'll come in, they'll look at this file system structure, but they won't be able to relate that back to their code content. So that's bad. And so that's where I think that some of these visualization technologies can go, should have built that better. So what we've got here is we've got the code sitting in bench. That's all the stuff that does something. Test, nicely separated, and then there's this demonstration branch down there that relates to some stuff I've got on the wikis. I've got like tutorials, but I've integrated them into automated tests so that when you actually run the tests, you can also run all of the things that are actually on the wiki, so they're guaranteed to be good. Every time you do a software push, you know that your website's still functioning. So I really like that. I find that quite easy to relate to. But one of the things about all of these pictures that I've shown is that they're just one at a time. You're not going to be able to necessarily know whether it's important to just look from the top level. If we go back here, maybe what you care about is the details of one of these other things here. So really, you want your tools, they really should, where's this play button? Be interactive. So you should be able to grab one of these things and then just focus in on it. So you can see here that under its branches, straight away, you've got your release structure just visible in the file system. You can scroll around, and you can imagine if you were a new developer on this particular application, being able to go in and inspect the system in this way is, I think it's pretty powerful. And if you're also, perhaps like me, not as active in coding as once you were, and you're a bit out of touch with your own system, you can go in there and you can remind yourself of what the structures are and what the file systems are as they change. So here we go, I'm just diving into the matplotlib actual source code because I've decided I'd be interested to see how it actually gets built. This source directory looks kind of interesting, and I can go through and just do some more investigation. Now, you don't learn anything earth-shattering out of this, but it's another tool that you can bring to bear. So now this is a little bit about my ideas about how we think about architecture. Now, I was going to do a bit of back and forth at this stage, but I've been told I have to keep all conversation till the end for the video editing purposes. But I'm just going to not do that and ignore... and I want to ask the audience a little bit. First of all, I want people to feel free to just interrupt me at any stage. Can someone please interrupt me right now? No. Excellent, great. So that's how this is supposed to go. Right, how do we think about architecture? Someone stick up their hands and say something they think has to do with their architecture at work on the software that they build. Are these the questions that relate to you? Just yell, don't wait for the microphone. Nobody has anything to say about their architecture at work. Well, that's like where I work too, I totally understand. Okay, so architecture is like design patterns and client server and web and Django and templates and all of this stuff. But as just a person trying to relate to some software, I find all of that just too hard. I'm sorry, it's just too hard. I want to know what it does. I want to know how I use it. I want to know its parts. I want to hack on it. If I get really serious, I want to know how it performs, and I want to know where it starts and where it's good at. I want those human questions answered, not technical design analysis. That's the job of when you're analysing, when you're improving, when you're working. That's past this. Straight away, I want to go, first glance, what do I need to know about this thing? So by looking at the directories first, that's what most of us do, right? You look at the docs and you read something about, oh, you import this and there's this code snippet. You don't know what's going on there. You go, really? Is this it? Look, I better just look at the source code. The first thing you see is the directories. And I think this is actually good because it encourages top-down thinking. So a lot of people think that when you're designing, bottom-up's what you should do, because top-down concepts don't tend to hold true. They tend to have cruft in them where, you import it and you just have to initialize this thing and you just have to know about it. So people sort of get more comfortable with bottom-up. All right, let's get our data structures right, or let's get our bottom-level functions sorted, and then the structure will kind of emerge. And that's fine when you're building something or when you really know what you're doing, but when you're being introduced, that's not how you see something. You see it top-down. You go, if you download a new API, you just want to use it. You want to know, okay, where's my first tutorial so I can see an example of how this thing gets used? What do I have to do at the top level? And I think that as designers, we should actually be thinking from the top down. And this is roughly where I think I'll lose a lot of people, because I think that's not really quite normal. But that's how I like to think about architecture. And I'm not trying to tell you to do it that way, but do it that way. But hey, even if you're not going to, maybe these tools will let you do whatever you want to do your way as best possible. So top-down is how we introduce people to systems. Top-down thinking is the essence of abstraction and simplification. If you never did any top-down thinking and you only ever did bottom-up thinking, you would never be able to get away from having to understand everything at the bottom level. The only way you get away from having to understand everything is by going up a level and accepting the abstraction, trusting whatever it is that's built at that mid or higher level. So I really would argue that your directory structure is actually part of your code design, and you need to relate it to the code content first. So it's not big design up first. It's not what's written in some diagram, and in this case I didn't mind like an XML diagram or a use case diagram, or something someone wrote up for marketing with a picture of a server and with a particular shape over there, and like a square and a cloud, because they lie. Those diagrams lie. So you can't just trust them. You can trust tools that you're using to inspect your actual code, which is where I'm coming from. Take a look at your actual code so that when you're just sitting there interacting with it, none of this is hard. You just pull it up and take a look and have a mess around. So it's structure. It's all of these things, okay? It's your choice of operating system will inform your architecture. Maybe it's part of it, maybe it's not. But after a while, you realise that just kind of everything's architecture. Could be, maybe, depends on your problem. So one of the things is that architecture really relates to the problem you might have at hand. So at work, the stuff that I do turns out not to be very performance bound. That's not really the problem. The problem we face is coming up with like an interesting solution to an interesting question. So we'd be quite happy to compromise some aspect of our architecture if it let us express our business rules like ridiculously clearly. It wouldn't really matter if that was slow or if some software engineer had to do some more work. The most difficult thing we have is talking to our users about our requirements and expressing them cleanly. And if we can do that, that's solving our problem, because our problem is relating to our users. So your architecture might be, you might go, oh, I really need to make this a low-level concept, and it's really important to me that there's some client-server interaction going on here, and I really need to get my network channel organised. And that's great if you're trying to scale something or build for the cloud and your primary problems are technical. Great, then that's your architecture. That's what should be up front. For us, what should be up front is our business rules, our rules that say, well, if it's in 4 days' time and we think there's a 20% chance of rain, then we'll say scattered showers, or should we say something else entirely? And the details of how we do the processing are less important. They're not irrelevant by any stretch of the imagination, but they're not necessarily what you need to expose first to someone coming to try and understand the system from a top level. So really, it's the analogies that you capture in your system. that are your architecture. So good code structure corresponds to your content structure. So your file system, you've got this particular mapping. When you go to the main objects and the main parts of the system that you're going to work with to extend it, that corresponds well to your file system layout. And that corresponds well to the problems that you're trying to solve for your users. So good architecture is context sensitive. Makes important things available while hiding unimportant things. You get the idea. So let's take this be a bit more practical, like I've got an actual problem to solve. So this is where I rip into my own software like nobody's business. So where is it slow, where is it fast? Here, my software is working pretty well. So this diagram here is now based off a dynamic analysis of my code. So I've produced an XML document which says how long, when running all of the tests, everything took. You know, I just ran profile, put that into a tree structure based on my file system, and then made things colors, and then fed it to this tool. Well, I made things numbers, and the tool made colors out of the numbers. And straight away, you can't look at anything else on this whole picture except bubble sort. Nothing else is of any interest whatsoever. The only thing on here that you can even see is the thing that's bad. So I don't need to think at all. I just really, I should just stop bubble sorting lists. It's a terrible idea. So that might be, you know, pretty obvious. You wouldn't do that anyway. But this is the kind of thing where if you wanted to, say, convince your manager that you really needed to optimize your bubble sorting, or perhaps not do it, you know, you could pick this up and go, this is a diagram of our whole code base. This is everything we do, and the only thing that's red is this method here. It's the holdup. I know you don't understand technical problems, but like you understand when something's red, and this one's red. So, you know, the fundamental principle I have here is if you actually show someone something in a way that they can relate to, you won't have to convince them of why something's a problem. You go, I have to work with this rubbish every day, and you know, I know you don't care whether it's red, you care about whether your business problems are being solved, but this is causing me a problem to get that done. Okay, so straight away they can go, okay, so you've analysed it, you've got a thought process, you've got a justification, it relates to the work that you need to do, and it's red. So, you know, so straight away, you know, I just think this is a great way to relate to people. This is my content structure. So this is the classes. These are the code dependencies of the things in what I just showed you. So this is fine. Oh, a neat little trick. So this is I should have been playing this video all along. This lets you like dive in. So I'm clicking on the left and opening subdirectories on the right, and now I can really see that it's bubble sort that's bright red. So once again, if you have a big project or something, this particular tool, it's called TreeViz. I'll share my actual slides. All of the links to all of the stuff are in my slide notes. So if you want stuff, it's in there. So there we go. You should make it dynamic. Now, where was I? Yes, bad structure. So this has nothing to do with that file system diagram I showed you. Can any of you see any links? I sure can't. So, you know, straight away I've broken one of the relationships that's in my system. Maybe this is actually not a bad code structure. Like maybe. I mean, you know, it looks fairly bad. Most of that, I think, is because I'm doing things like running tests which interact with lots of parts of the system at once, because this is based on a dynamic analysis. So I tried this other way of structuring the diagram based on a force model that the software also does, and it didn't look any better. So, you know, probably I need to go do some work. Also, these things fail for large diagrams. This is that same picture for all of matplotlib. So that fuzz, you can see the fuzz fairly well on this projector. Most of that fuzz is little tiny lines between connectors. So when you get up to large pictures, you need to be able to dive into this stuff. So large diagram fail, unfortunately. And that's most of where I've got with these pictures. So mostly what I want to go from here is, okay, so think. What's important about your applications that you need to look at? So I want someone who's working on some code that doesn't understand something to stick up their hand and say, what is it? Can anyone think of anything they could apply to these tools to? Yeah?
Implementing data tables tags in the Django application, and where they're making calls to the database to the Ajax.
Right, so I'll just repeat the question, Mike. Okay, so the question was, he's got a web application and he's got a data model and he doesn't understand exactly what's making what call. So it's a kind of complicated piece of debugging that he's got to do. And you could put a breakpoint in or something, but that doesn't show you the structure. That may be an analysis tool. But if you want to try and learn, so I have similar problems at work. It's not a database thing, but I need to work out where in some kind of complex relationship something's actually getting called in the first place. I can sit down, I can load up WinPDB, and I can go, I put a breakpoint here when it's been called from this module, if it's after this condition. I can build up, based on my own analysis, some complex way to get at the problem. Or I could just as easily record this stuff in this kind of tree structure which I've designed before. So I could do things like say, all right, rather than that, I'll wrap a decorator around my function and I'll work out who's calling me and I'll put +1 on a counter that makes that relevant, and then I'll just build a whole tree diagram and say, okay, so what parts of the code are calling this thing? And possibly at what stage in the execution flow. So this is where we could, it's now very open-ended. I'm not trying to tell you which one of these things is important. Someone else might be their CPU time that's really important, or their network overheads, or they might need to do a percentage graph of why does it slow down sometimes, or what time of day, relating these numbers together. So that's where I'm sort of headed with those, is that I really want people to, if nothing else, just check out these two tools, TreeViz and Gorse, and just watch them. Don't even think about it. Just go, hey, that's really interesting. And now I've got some Python code I'm more than happy to share for building up the tree structures that let you take a new metric like line count or coverage or CPU time and get it into that structure. So, just approach me. So crazy ideas. Okay, you've looked at one of these pictures. Why not simplify your architecture based on these dependencies or based on CPU time and go, look, I know it seemed important to fixing this problem, but it's detrimental to people understanding this code. Why don't I use these diagrams to go, that connection there should have got severed. So if I go back to my picture here, I might well understand that, there is some structure that I can see. I've got to watch the thing. There's structure down here, that's fine. This structure here, that's not too bad. These things are just pointing out to the tail nodes, that's good. But, whatever's going on here is clearly a problem. This large reach up here, what's that about? So I would argue that actively using these tools to go in and analyze your architecture is something you can do. So, tools of the future. These kinds of things should be really easy. I had to search for quite some time. I was very careful to make sure that I only used tools that already existed, that were really, really easy on account of I'm really, really slow, and that anyone in the audience could go, hey, I remember that thing that guy said, I'm just going to check it out and take a look. So all of these tools do work now. I think that some of this stuff should be in your editor. We shouldn't end this with a tool that you have to go and explicitly run and use, even though that's useful. There should be things should be part of your GitHub metrics or on. There was that fellow, I don't know if the guy from SourceForge was in the room who gave the previous keynote, but he, that's something that he could implement, these diagrams. That could be a selling point for how to look at your project hosting. If you have lots of projects at work and you have some infrastructure for standard ways to set them up, make some of these diagrams automatically. Integrate them into your automated documentation. Make them something that goes out to new developers to give them a hand. Pull them into your editor. Make these things colour your line counts so that you can see lines of code or functions which are heavily used to be a flag to any developer that comes across them that they're important. Take a look at what some other people are saying about the visualization of ideas when it comes to code. Take a look at Lighttable, for example. See the ideas that they're putting forward. So that's the refresh rate. Apparently PowerPoint just quits when you get to the last slide. So, for better or for worse, that's my presentation. Does anyone have any questions or comments? Down the front here.
If you can wait for the mic. Yeah, basically we have about 5 minutes for questions, so, okay.
Thanks for that. I've been playing with hyperbolic tree views for some time, and one of the things that bugs me, I don't know if it's because Xerox has a patent on one of the algorithms, but there doesn't seem to be an open standard for being able to switch between viewers, so you kind of spend a lot of time converting your data for a particular viewer, which then goes out of fashion and it's not built in. Have you got any thoughts about what parts of this space would be best suited to focus the open source community on?
Well, the TreeViz application that I use to build these diagrams happens to do a good number of diagrams. It has a very amenable XML format underlying it. So yeah, you're totally right. No two applications will use the same thing. It's not terribly visible which applications are good or not. It wasn't just like, oh, Google tree visualization hit #1, go. There was a fair bit of that didn't work. Can't get the libraries for that. That's out of date. It ran. It didn't. There was a lot of just stuffing around. So I guess my main recommendation would be use this one because it's like it actually does the business. And also the XML things, you can reuse them yourself. It's actually a really sensible file structure. So TreeViz was the Google search.
Hi, thanks for the talk. With the keynote this morning and, kind of this call to arms for having more developers be managers, and it sounds like you're kind of in that category. I'm just wondering, do you feel that these techniques are helping you, tell the bosses, here's the red light, and actually, do you feel it's really being effective in the way that you can help manage the team and work with them, or even, maybe better express these things to senior management so they actually understand what's going on? Can you talk a little bit about the value of these in what you do in your job?
Yeah, absolutely. So this is a little bit of a tangent, but so my role is now I manage between 1 and 4 developers at any given time. That sounds like it should be a lead developer role, not a manager role, but it isn't. It's a manager role where I work. And so, yeah, I very much exist in that space between like arguing for timelines, talking about why we need to go maintain something, et cetera, et cetera. And these things are of incredible value in persuading your manager that you've got an actual proper good reason. Because everyone knows that developers are smart, but it's often in a kind of dangerous way. And so you really need to convince your manager that you're smart in a safe, trustable way. So I would say that it's not about taking to your manager and having your manager do a problem analysis and come up with an agreement to your position. It's not going to happen. They don't have the time. But what will happen is that you can expose your thought process, put a sensible justification for it, and it will make your job a lot easier if you can use diagrams, illustrations, and a simple case for why it is that you need to do something. So super valuable from that perspective.
We don't have any more time for questions, so I'm going to have to wrap it up here. But I'd like to thank Tennessee for giving the talk today. We've got him, round of applause. And he gets a nice coffee mug and some African swallow coffee, which you've been trying already, so it's actually pretty good.